Hey guys, so in this video we're going to create Claude, a simple but powerful coding agent that's going to help you with your code, similar to what Claude Code or Codex agent does. So we're going to build this completely in Python. So the prerequisite for this video is that you need to know Python, how it works, basic syntax, and some string manipulation techniques. So yeah, so it's going to be pretty simple, and we are not going to use bunch of libraries. These are Claude agent. I'm going to show you what it can do with a simple prompt. So I'm gonna tell this to create a simple Space Invaders game and run it for me. So it's gonna go and make a game and run it for us. So let's see what it does. Okay, so it's first inspecting where the Python is and the versions of Pygame. Okay, so it has created the game and started it for us, so let's play it. So it kind of looks pretty good. So this is just an example of what it can do. It can do a lot of things. So let's start the video. So let's first understand by making calls to the LLMs and understand about how history works. So I'm going to be using light LLM, and the reason for that is you can use almost all the models with this. For instance, I'm using DeepSeek V4 Pro right now. If you were to use OpenAI's model, just replace this with this key and the OpenAI's key, and it will work likewise. So this is how we first make calls to the LLM. First, we have to understand how a message is passed to the LLMs. First, there is this type of JSON structure where we have key role and value systems and content and the message that we want to pass. So there are a couple of roles. First one's the system. It's kind of like the default prompt that we cannot change, and there's the user where a user passes their message. For instance, in this case, we have where is Mount Everest situated. So our history will be a list of this type of JSON. So we simply pass this history to our completion method, and and then we call it. So the answer was simply this. So it said Mount Everest is situated in the top range of the Himalayas. So you need to be careful of one thing. So as you can see, it has finish region stop. So what does this mean? So it simply means that the model has decided to stop because it has finished answering. So this will be crucial in the later stages, which I'll tell you just right next. So let's say we have our first response and then we want to ask it another question. So the another role that we have is of assistant. So it simply means the model's answer. For instance, in this case, we will be simply passing its previous message. As you can see, we'll be passing this content, and we simply pass another role. So here we are asking, and what's the first base camp there? So when we ask a question about the first base camp, we haven't told the model which mountain we're talking about, because it should know that it's about Mount Everest, because we have in our history the question that we have already asked. As you can see, where's the Mount Everest, and also the answer, also its previous answer. So when we run this, we will get the answer. The answer depends on how defined first and main base camp. As you can see, there's the south base camp in the Nepal side, and there is the another north base camp in the Tibet side. So yeah, so this is how we make calls to the LLM, and this is how history works. Now I'm gonna take the same code and make this more structured. So we're simply defining a class nano-Claude. It's gonna have some init function with initial history. It's the system prompt. This is one step where when a user asks, this is where the completion happens. So the params is simply the model. In config we simply have the model right now, but you can expand it to include other parameters, such as the amount of tokens that you want to be processed, and so on and so forth. And we have a function called execute, where it takes a user message and adds it to the history, and it's gonna do one step of it, meaning it's gonna pass this message and get its answer and return the response. And if we have some content in the assistant message, then we're simply printing it. And remember the finished reason stop that I explained earlier. So when the finished reason is stop, we are simply breaking this loop. So now you might be asking why there is a loop inside this execute function. So you'll understand this just right next, because we will have tool calls that we want to be processed. So just know that it will be used just right next. So when the finished reason is stop, we simply break this loop. So this REPL function simply gives a nice interface to our model. So we are defining a while loop where we first get the input from our users, and if messages are quit, exit a queue, we break it. If not, just continue taking the question and convert that instruction into a content. So you might have noticed that we define two classes for content and message. So we are just simply providing a simple structure. A message has role and a content. Previously we simply had a string, so it can also be a list of content, and the content is simply type and a text. So we are just making it more structured. If you want, you can simply use the role and content with simply a string. So yeah, so we construct the user message, and then we pass to the execute function. It's gonna take the user message, run this loop, run this step, and print if there's any answer, and stop if the finished reason is stop. So let's test this. It's the first assistant message. It will also have notion about our history. As you can see, the execution was finished because the finished reason was stop. We ask another question which gets added to the history, and it answers likewise. It's located, as you can see, it knows it's the Mount Everest because we append the previous question to our history. And yeah, so it has again finished its execution because the finished reason was stopped. So now let's understand about function calling. which is the backbone of our Claude agent. So what function calling does is it gives access to our LLM to execute a function. So for instance, let's say we ask what's the temperature in Tokyo to our current LLM. Then it would simply say, I don't know. So you can see I just asked. So to our current program, what's the weather in Tokyo? So it simply said, I don't have access to real-time data. It knows that it doesn't know the temperature or the weather in Tokyo. So what we use is call function calling or tools. So it's kind of like giving access to our LLM about a function. Let's say we now create a function called getWeather that accepts a location argument and give that to our LLM. Then what our LLM can do is it can choose to execute this function during its execution, which we'll see right next. So it's kind of like giving our LLM an extra function or extra tool that it can execute during its execution. So how do we provide this function to our LLM? So as you can see, the structure is pretty similar to what we did previously. We have our system prompt and user's question and a structure about a new function. So it has this type of JSON structure. It's gonna have type function, and inside the function it's gonna have name, it's gonna have some description. So we will write this description pretty clearly so that it knows when to use this function. And it's gonna have parameter type object and the property location with type string and required location. So which means that it must always output this location argument. So now we create a tool. So if we want to create multiple functions or tool like this, we just append to this tool list and we will pass this tool to our current LLM. So now we will pass this tool to our current LLM. Previously we did not have this tool. So right now it simply knows that it can call this function, but it doesn't know how to execute because the execution part is in our hands. So which we will see right next. So when we execute this, we will get a response like this. So remember, the finished reason is not stop. Right now it's tool call, meaning we will have to call our tool. So now that our assistant or LLM has decided to call the function getWeather with location Tokyo, so it's on our hand to execute this function. This execution function can be an API or something where you can get the information about the weather by simply passing the location. So right now we will simply hard code it. For instance, here we process our function calling. Say if our first message had tool calls and the tool's main was getWeather, then what we would do is simply append it to our history, the previous message this with empty content, role assistant, and the information about tools and the other information. We append it to our history, and this is the point where we process. I'm simply getting the location Tokyo here by extracting the JSON, and I'm calling this getWeather function. So this can be our external APIs where we can get the information about this specific location. Right now I have just hard-coded this function which will simply give us this sunny weather, temperature 20 degrees Celsius, so on. And after we have the output, we simply append it to our history. So now you have to be careful, because you have to be careful about the role. Previously we had roles of system, users, and assistant, and now we have the role type of tool, so which will mean that it's the output of calling our tool. Here we also pass the tool ID, and now that we have appended to our history, let's now process it again. Now if we do the next step, our LLM has information about the weather in Tokyo, and it's gonna respond it with weather in Tokyo is sunny with temperature of 20 degrees Celsius. So if we were to visualize this, it works kind of like this. We have first user asking the question, what's the temperature in Tokyo? The LLM now has access to get weather function, so it decides to call this get weather function, and we execute this function. We simply hard-coded this 28 degrees Celsius. Now this information is then again passed to the LLM, and it then decides to give its final answer. So in its final answer, it will have finished reason stop, but during this process, it'll simply have finished reason tool call. So now let's add this function calling feature to our existing Claude code. So the changes that we make are pretty simple. We first define this get weather tools function structure, and in our Claude class we add a tools attribute, and then pass this tools here in our step function. And so this is where we have extra changes. So if the finished reason is stop, then we simply break out of this while loop. But if we have a tool, if we have tool call that was called by our LLM, then we need to process that tool. What we do is we simply append the assistant message to our history, and we process or we execute that tool. So if the tool name was get weather, we would first extract the location, and then we pass this to a function. This could be API or some other external functions. Of this output, we simply append to our history with role tool and the output of it. So in this case, our LLM decided to call tool, so meaning there is no finished region, so it's going to continue this loop and it's going to do another step. Now our LLM has access to the information about the get weather, which we got from this function, where the output is sunny weather with temperature 28 degrees Celsius. It's going to process this information and give us our final output. And in the final output and in the assistant message, it's going to have some content in it. We're going to print it, and its response and its finished reason will be stop, so the execution will be finished. So now let's test this feature that we just implemented. Let's ask what's the weather in Tokyo. So it's gonna go call the function. As you can see, the finished reason is tool calls with function get weather and the location Tokyo, and we execute that function internally. We simply hard-coded that value and then again pass that to LLM, and it's going to process and give us the answer. The weather in Tokyo is currently sunny with temperature of this. So this is how it works. So this is going to be the backbone of our Claude agent, and we are going to implement some pretty interesting tools with this function calling feature. Let's now introduce some terms so that it's easier to understand what we will be doing. So the flow in our agent will be kind of like this, where a user first asks question to our LLM, and then decides to call some function. Then after calling that function, it's going to perform some action. So this could be executing another API call or another existing Python function. So we are going to name this phase by perform action, and after the action has been performed, it's gonna output something. So in previous case, it had weather sunny and a temperature 20 degrees Celsius, so which was the observation. So any output from this action function is the observation, and we pass this observation to our LLM, and it's going to give us the final answer. So let us now implement a powerful tool called bash tool. So with the help of this tool, our LLM can execute commands in the terminal. So the first phase is by simply defining the structure for our tool. So we define a bash tool, and the structure is pretty similar to what we implemented before. It's gonna have function name and description, and it's gonna have some parameters. So for this, it's simply going to be a command. So LLM will give us one command, and this tool will execute that command. So I have also written a detailed bash description, so read it if you want to, but so it's simply saying that just execute one command at a time, and some other additional instructions. So we've defined the structure, and in our tools, we are going to add this tool, bash tool. We have removed the get weather function because we no longer use it. So let's remove this. So it's gonna have bash tool, and at this stage, it's gonna have some tools that will be called. So we loop through the assistant messages tool calls because we can sometimes have tools that will be more than one, so we have to loop through it. So I have moved this code to a perform action so that we are inconsistent with our description that I just gave earlier. I'm gonna remove this to perform action tool. So if there's a tool, we pass this to perform action, and in that function we're gonna extract the function name and implement this if condition. So in this case, if the tool name is bash, we're gonna extract the arguments, and we're gonna extract the command parameter and pass this to a function that we will implement next. So this is the structure. So this is how a tool will be called by LLM, and we will now execute this command. So now let's provide an interface where we can execute this command. So we're going to do this with the help of libtmux, which is simply a Python wrapper for tmux. So we don't need to know in detail about what tmux is, because we are only going to work in a single interface that's called a pane, where our LLM will execute one command at a time. So just a quick introduction about tmux. So a tmux is where we can create multiple terminal windows where we can execute various commands. So first, a tmux is gonna have a session. For instance, in this case, let's say I'm creating a nanoclass session. It's gonna create its default window, and let's create a new window. So as you can see, it's created a new window, and we can create some panes. So as you can see, I've created a horizontal pane, so I can execute two different commands here and here. So this is what basically tmux is. So we're only going to work within a single pane, so we don't need all of this info about tmux. So we are now creating an interface for our LLM to execute some commands. So this is how we do it. We have some init function with a working directory, username, and server attributes. So work directory is simply the directory we'll be working on. Our username, we're creating a tmux server here, and with initialize method we are going to create a new bash session in this working directory. So we're going to set some limit of 10,000 lines in our tmux window. What we do is we first get the first active window and we're gonna just kill it. So before killing it, we have to create a new window. So we're gonna run bash in that window in our working directory. We're gonna kill that initial window. The reason for this killing is because the initial window has some restrictive limit. So what we do is we select the active pane and then clear whatever it is in our default pane. So this is how we initialize. So this clear pane will simply clear whatever there is in our pane, and this get pane content will get us whatever there is on our pane. So the most important method is the execute method, which will execute our command, the command that our LLM will give us. So what we do is we take the command, we send that command to our pane and wait some time so that the command has taken some action, and then get whatever the output is on the pane. For instance, let's say our LLM has given this command. We take this command, pass it to this pane, which is in this default window, and then execute it. So, and it's gonna give us this pane content. So now let's define our working directory and the username of nanocloud. Let's initialize this bash and execute this ls-lh command. So as you can see, this is how the command will be executed and the output will be visible to us, which will then pass to the LLM. So now let's expand our bash interface, and the reason for this is because we have no information about where this command was executed and whether this command was successful or not. Or so what we do is we add some information for each command. So we do this by adding ps1 and ps2 prompts. So the structure is kind of like this. It's going to start with this ps1 JSON and it's going to end with this, and in between this we are going to have this template where it will also have information about the program ID and the exit code about exact command, whether the command was successful or not, the username that executed that command, the host name, the working directory, and the Python interpreter path. So what we do is we create a new window, kill the initial window, and in that initial windows pane is we export this command, this ps1 command, and we get this command from this class's class method. So it's gonna build us this template. So exactly at the start of this terminal session, it's gonna set this ps1 prompt, so it's gonna be clear when we execute this command. So let's first initialize our bash session and let's execute this command. So as you can see, so previously what we had was we simply had this bash 3.2 $sign and then the command. It's gonna have some more information that will be useful for our LLM or the agent. So as you can see, it's gonna start with ps1 JSON and end with ps1 end, and here's the structure, and the program ID was this, the exit code was this, username this, hostname this, and the working directory was this. So, and then the command that was executed and the output. And it's gonna end with this as well, because it's now asking for another command here, similar to what we had here. So now if we were to execute another command within this same session, so it's gonna give us this. So it's gonna give us the full history. As you can see, this was the previous command, and this was the next command, ls videos. So it's gonna have 2 folders. So this is how we provide the ps1 prompt to it. Now at this point, this execute function is enough. We could simply do return whatever there is in our pane, and the LLM would see these output in its pane, and this would be enough. But what I'm going to do is make this output a bit more structured for the LLMs to see. For instance, I want the output to be kind of like this. For instance, let's say we enter ls some folders, it's gonna give the output. If there's another command, ls papers, it's gonna have its output. So this is the history. And also what I'm gonna do is add the current working directory and the Python interpreter information and the exit code about the last command that we executed. So I'm gonna structure it in this way so that it's easier for the LLM to understand. Let's expand the execute function. So what we will do is we read whatever there is in our pane and we parse the content in that pane. So what this parsing does is it's gonna look for the content in our pane, which starts with this, ends with this, and whatever there is in between. So it's gonna match blocks like these. In our example, after typing this ls-lah command, it's gonna match this block and this block. So after this command, we will have 2 matches. So at this point, assume we haven't typed any command. So what it's gonna do is it's gonna simply match only one JSON, because there was no command executed. There will only be this within our pane. So init marker count is just 1, and when we type the ls-lah command here, we're gonna send this command to our pane, and we're gonna wait some time, let's say 0.5 seconds. So we run this loop until this hard limit. After this, we will simply time it out because we might suspect that the command has been stuck. So we set some hard limit, and so within that hard limit, what we're gonna do is we're gonna get the pane content and we're gonna simply parse the block. So now after this ls minus alias has been executed, it's gonna have this output in its pane and another block. So the match will be increased. As you can see, so its matches length will be 2. So initially there was 1, so now it will be 2. So this condition will pass. So now what we do is we slice the output between these markers. So what this means is we simply get whatever there is in between these markers. So between this marker and this marker. So we're simply getting the command and the output. So we're gonna slice these into segments and we're gonna join these segments and pass it to our CMD output observation, which looks like this. So it's gonna have content and it's gonna have metadata. So as CMD output metadata looks kind of like this, what we showed earlier. So yeah, so when we call to agent observation, it's gonna structure this for us. For instance, it's gonna wrap the content within this result tag, and if the metadata contains work directory, it's gonna also add this structure, it's gonna also add this Python interpreter, and it's gonna also add this execute code. So what we are doing is we are simply finding the tags, parsing these tags, and getting whatever there is between these tags and constructing our CMD observation. So you'll understand when I run this. Let's initialize this, and let's say we run ls videos command, and we also want in this format as well. So it's gonna give us this ls videos command that we executed, the output of it, and the current directory in which that command was executed by the interpreter and the exit code. So we add the structure to the ending command only. So what this means is, let's say we execute another command after this command. So it's gonna have content of this, but if we also want in this format do agent observation, it's gonna give us in this format. So this information relates to only the ending command. So yeah, so this is how we structure. So yeah, so this is all about constructing an interface where our LLM can execute commands, and after executing we provide that observation or that output back to the LLM so that it can process. So as you can see, I'm just copy pasting this part of the code in our NanoCloud agent code. And what we do is in our init function, we initialize our bash session, and when the LLM has called a specific tool, we will perform action, and in this action we extract the function name, and if the function name is execute bash, and we're gonna extract the arguments, we're gonna extract the command parameter and pass it to our bash sessions execute function, and we're simply going to get this observation. As you can see, the execute command is similar to what we explained earlier. It's gonna first get the pane content, parse ps1 block, and send the new command, wait some second, and within this timeout it's gonna parse again and see if there is extra ps1 matches. If there is, slice the output between matches and then join the outputs. So yeah, so this is how this bash session works, and let's test our bash session tool. See what are all the files in this directory. It's gonna go and it's executing this bash tool. Now it's okay. Here are all the files in the current directory: dsstore.git and the nanocloud file. So yeah, so now our LLM has access to a bash interface where it can execute the command. So now that we have added our bash tool, let's now add another tool called a file editor, which means giving LLM access to edit our files, create files, insert some lines, replacing some lines in the code. So we'll have these 4 functionalities right now. So first, it can have access to view command. So this tool can view a file from start line to end line. For instance, let's say we have a code and we want to read the code from lines 51 to 55. So it's gonna come open this file and get this lines of code from 51 to 55, and it's gonna have access to create command. So with this it can simply create a new file with some content, and can also have insert functionalities. So let's say at this 52 line I want to add some code, then so it will come at this 52 line and add some extra blocks of code at this specific insert line, and it's gonna have string replace functionalities, which can replace old string. For instance, let's say I want to change this style block with 50% and height 50%, so it's gonna come and change this style block. So yeah, so we will be implementing this. So let's first create the editor interface, which our LLM can use to execute its functions. So it will have view, create, string replace, and insert functionalities. We have undo edit, which we will not implement in this tutorial. This is where the code starts. We define an editor class. We're gonna initialize nothing here. It's gonna take a command, can be one of these, and it's gonna have paths to the file that we want to edit, and all these variables. These are specific variables which can be used for different commands, which we will see right below. For now, let's implement a view and a create functionality. We first take the path from this function. We check if the command is view, and if the view has range. So as I said earlier, it's gonna have start line and the end line from which we want to view. So from this path, we want to view from the start line to the end line. So what we're gonna do is we're gonna read the file from this line to this line. This read file function is pretty simple. What it's gonna do is, if the start line is none and the end line is none, it's gonna open the file. We create a list, a temporary list, and we iterate through that file, and if we are exactly at the start line, we append that line to the text, and we go on adding the line to our text. So after this ending point has reached, we break out of this loop and we join this text. So it's gonna give us it's going to give us a particular part of code that we want from start line to the end line. So this is pretty simple. So if there is no start line and end line, it's gonna read the complete file. So this is how a read file works. As you can see, there is the else command. If there is no view range, we're gonna simply read the entire file. Now after this command has been executed, we're gonna save this out in our success message. As I said earlier, we're gonna define observation. So the observation is simply the output. So we're creating this observation with file path and the success message. And for create function, we simply implement a write file. So we're gonna write to this path with this text. So let's see how this works. We define the editor, and let's say we want to view this file path from 25 to 30 line. Now it's gonna give us the exact content from line 25 to 30. So this is how it works. So now let's implement insert functionality. So what this insert will do is, let's say this is a file, sample file, and we want to add some line at this third line. Then what we do is we first save this first two lines in a temporary file, then add to the temporary file new line, and then go on from this line to the ending line, and then copy this block to the temporary block. So this is how it's going to insert. For instance, let's say we have a command that checks if the command is insert. It's going to implement this insert function. So in this function, as you can see, it's pretty straightforward. It's going to work something like this. It's going to take path, the line that it wants to insert at, and the string that it wants to insert. So what we're going to do, we're going to simply create a temporary file first, and then open the file that is at this path. We first open this path, we iterate through all the lines in that file. If I is smaller than the insert line, what we're going to do is, in the temporary file, we're going to write that line. So what we're going to do is 1 and 2 are smaller than 3. We're going to write this in our temporary file. So if the I is greater than insert line, we're going to break out of this loop, and we are going to add the string that we want, the new string. So we're going to split it, and we're going to add this line by line to our temporary file. So now this line will also be added. Now we need to add the remaining lines. As you can see, we open the file again at this path, and if the I is greater than the insert line, we're gonna simply add to the temporary file. So now it's gonna be completely inserted, and what we do is we simply replace this temporary file with the previous file. We will have this file edit observation with this success message and this path. So let's test this. So let's first view what's there in this file. From line 30 to 35, it's gonna give us this. So now let's insert hello at line 31. So yeah, so it says it has inserted. So now let's see if it has. As you can see, it has inserted hello at this line. So this is how insert works. Now let's also implement the string replace function. So when the command is string replace, we're gonna run string replace with these parameters, the new string, the old string. So enable linting will not be used in this case, so just leave it as is. So in this string replace function, we will first read the file from this path, and we construct a pattern from the old string because this is what we want to replace. And what we do is we find the pattern in the file content. Now if there is a match, we get the exact line number where that old string starts, and the exact old string and the character index where that old string starts. So now if there is no occurrence, we simply raise tool error, and if there is more than one occurrences, then we simply raise tool error because we don't want to replace two blocks of code at the same time. So if there is only one occurrence, we get the line at which the old string starts and the exact old string that was matched, and the character index at which the old string starts. So what we do is we get from the file content exactly that is before that old string, add the new string, and then add whatever that was behind the old string. So for instance, let's say this is the old string. So we get when we find the occurrence, we get the line number. For instance, let's say it starts at 3, and then the exact string that we're looking for, and then another one is the character index. Let's say it's 1 2 3 4 5 6 12. Let's say it's 13 in this character index. So what it's gonna do is it's gonna collect all the characters until this 13 character index. It's gonna add the new string to it, and then it's gonna collect what is after that old string, and then it's going to write to that path the new content. So yeah, so this is how the old file will be replaced with the new string. So now we are constructing a start line and an end line here, and so the reason for that is so after the new string has been replaced, we also want the model to see some blocks of code that was before that new string and some blocks of code that was after that string. So we have snippet context window set to 4, meaning it will read 4 lines before that new string as well, and 4 lines after that new string as well. So it has a little bit of previous and after context. So as you can see, I have the start line starting just 4 lines before the replacement line, and the end line that starts at 4 lines after the replacement line. We're gonna read the file, the new file that we just replaced, from the start line to the end line, and we're gonna pass this inner success message, and then we're gonna pass this to the file edit observation. So now the LLM will also see some previous context. So now let's test this. Let's first view some lines from 65 to 66. We have this text, and let's say we want to replace this with new string nothing. So we're gonna replace this exact string with nothing. Then it's gonna also output us 4 lines before, 1 2 3 4 before that replaced string, and it's gonna also output 4 lines after the replace string, as you can see. So this part was replaced with nothing. So this is the replace part. So let's, if we view the new file, it's gonna have this text replaced. So yeah, so this is how we construct file editor. So now let's add this to our Claude agent. So as you can see, I'm simply copy pasting what I wrote here. So this is the editor interface, and so what we do is we pasted this. So we also need to create a function like we did for the bash tool. So this is simply like providing a structure similar to bash tool. So we create a file editor function with a detailed description. So I've written a detailed description here, which you can read. And it's gonna have parameters, command, the path, file text, old string, new string, insert line, and view range. So these are the parameters that our function will take. So LLMs can call these parameters. Now in our Claude code, what we're going to do is we're also going to define the editor, and if the model has decided to call a tool, it's going to perform some action, and if that tool name is file editor, so this was for the bash, and if the tool name is file editor, we extract the arguments, we extract the parameters, and then pass it to the editor, and then extract the success message. Now I also forgot to tell you about this convert observation to JSON. As I said, after every action there will be observation, so that observation will also be converted to this JSON format, because this is what our LLM will understand, not a simple string. So because it'll take the structure of role tool, the content, and the tool ID and the function name. So this is how we convert the observation to JSON. And now after this action has been performed, it's going to be added to history, and it's going to continue within this loop until the finish region has stopped. So we have now provided our Claude agent with two powerful tools. One is the bash tool, and the other one is file editor tool. So now these are so powerful that we might not even need to add some other tools to it, because for a coding agent, this is simply what we need. So now let's test our Claude agent. So we will test our agent by, let's say, creating a simple game. So let's tell this to create a simple Flappy Bird game in Python pygame, and we will also tell this to run it, so that it will also use the bash tool. So let's see how it does. So we do not have information about which command it's executing, what code it's writing, which file it's editing. So we will be implementing it next. So we will be decorating our Claude agent so that we know what's happening inside. So let's first check if this works, and we will be implementing the decorating part. So I guess it has now created the game. So let's play it. So it's done pretty good. So as you can see, it has executed a lot of tools within its call while it was creating the game. So it is first executed bash editor. As you can see, the assistant also says that the font module has some compatibility issues. It's fixing that. Game is broken on Python 3.14, and it now uses Python 3.14, so on and so forth, and it has finally finished its execution. So yeah, so this was pretty simple but powerful NanoCloud agent. So we will be decorating it next. So we will now use our NanoCloud code agent to improve our NanoCloud code agent. So I'm going to try to prompt it to create a splash screen that says NanoCloud code, and also decorate what command is being executed and tools are being executed with what parameters, so on and so forth. So let's see how it does. Okay, so let's see how it looks. What's this? Node. It looks pretty good. I got your coding agent. It's running in this. Started at this time. Hey. Okay. Create a snake game and run it for me. Let's see how it looks. Let's see how the tool call output looks. Okay. Tool call was executing bash. Still it's executing, finished. It's thinking what to do next. The interface looks pretty good as well. So it's done a pretty great job of creating this agent. So yeah, so this was how we created a simple but powerful agent, and then we used the same agent to make changes to our own agent. Now I'm gonna try to make this look a little bit prettier and also display some outputs. Okay, so let's see. Let's quit this and run it again. So great, so we also have some of the outputs. So this is what I wanted. Now let's also improve the splash screen. So now let's also try to make this splash screen a bit more prettier. Okay, so after a lot of hustling and bustling, it has completed. So let's see how it looks. NanoCloud. It doesn't look pretty good, but it's fine. It's looking fine. So all the code for this project will live in this GitHub repo. You can also see the commit history So the commit history is in accordance with my video, so which you can take a look at, and there's also the tutorial notebook file that I'm using. So yeah, so there's one request that I need to make, so please consider supporting if you can, because I'm not even monetized, and video like this takes a lot of my time. So thank you for watching, and see you again.